let me get to the exciting and interesting part, which is introducing this morning's keynote speaker, David Weinberger. So I first became aware of David back when I read the Clue Train Manifesto, which was when he co-authored that one, and that was a long time ago. Of course, neither David nor I have aged since that point. I want to make this very clear. He's written a number of books since then. The most recent one was Everyday Chaos. That was published in 2019. He's long been affiliated with Harvard's Berkman Klein Center for Internet and Society. He's been editing some books for MIT Press. And really his ideas about technology and its effect on both our business and personal lives have continued to fascinate me ever since Clue Train Manifesto, come to think of it. But now that I have this new position, editing KM World, I get the added privilege of editing David's column for that publication. And as I told him earlier today, he really doesn't need that much editing because he's really good. And I have a jump on everybody else in knowing what his most recent thoughts are, because I get to read it before any of you get to read it. This morning, he's going to share his thoughts about AI, the world of data, and just a trigger warning for you. He has a PhD in philosophy from the University of Toronto. So now let me turn it over to David.
The traditional, I don't have to do it, you can hear me. Hear me all too well. So thank you, Mary D, and thank you for the always excellent and very friendly editing. You make everything better. It's been a pleasure knowing you for a few, very few years. A few, yeah. Clue Train came out in 1999, so that's a while. So I'm glad you mentioned, I usually don't mention the PhD in philosophy because that was a long time ago, but as I've gotten older, I've realized I've started reintegrating that into what I think and write about, and I'm afraid that you're going to pay the price for that today. Sorry. So the title is The World According to Data, but I don't mean it in the sense that, let's talk about, which would be very interesting, but I'm not going to do it, which is what is data telling us about our world, about political polarization or spread of viruses or whatever. I'm not going to do any of that. Instead, I mean by it something like what the only philosopher to be mentioned this morning will be first, on the first slide, and he's a horrible person. It's Martin Heidegger, who he died in 1976, a totally despicable human being in every dimension. He was a literal Nazi, temporarily. So, okay, have I lost you now? Because I'm about to quote a Nazi philosopher. He's a very important philosopher in the history of Western thought, despite his terrible, terrible personal life. And one of the things that he says that I think is really important, this is from 1954, is that technology reveals the world. And what he means by that, as I understand it, is that technology shines a light on the world, and different technologies shine different lights and highlight some things and cast other things into the shadow. And as our technology changes, so does our world and our understanding of our world, what the world is, how it goes together, and what our role in it is. So that's what I think he means, and if he doesn't mean by it, that's what I mean by the world according to data. What is data telling us about our world and ourselves? I don't have a complete set of thoughts about this, but this is what I've been thinking about. So I think we all agree that data has changed, data is continuing to change. And just real quickly, some of the ways that I think are relatively obvious are back when I was a boy, and an adult, at least for a while, data was taken to be a sort of raw material, and we could do great things with it. But more recently, thanks to the internet and particularly to AI, which is where my focus will be, it contains secrets. And not secrets, oh, we're more polarized than ever, but secrets that have real import to us. And I'll talk more about that. Our approach has been to structure it before we use it, of course. Now we're seeing great value in letting it more or less organize itself. And we see this in the internet, we see it in AI. This is just this overview and summary. We'll come back to that. Data has been something that we've used in measured amounts for lots of reasons that you know better than I do. Especially in both AI and on the internet, they're both characterized by this enormous tidal waves of data, which constitutes much of their value. It's really, it's remarkable, the switch. We frequently hear that data is the new oil, not a phrase I'm crazy about because I don't like the old oil, but nevertheless, I understand the point, and that makes sense. And yeah, sure, but it's also now, in some ways, almost literally the driver, especially in the realm of AI. So lots of big changes, and one of the biggest, which we're going to talk about in some detail, is the change from data being something that we think of as, or at least outside of perhaps this room, people think about it as mechanical, dry, meaningless on its own. It does great things, but it's just sand. It's not a human sort of thing. In fact, it's sometimes used as the opposite of what we mean by the full life of a human being, as opposed to being always stuck in the data. I think, though, that because of the internet and AI, in weird ways, data is becoming humanized. So I do not have to tell you this, but as you know, we have started with data by organizing it, by structuring it, by dividing it into metadata and data. We're going to always continue to do that, I assume, for lots of the applications where it's 100% what we want. But that distinction has been very important to us. And we know on the internet, 30 years ago, actually before Mary D. and I met, search engines had arisen and changed that. So in case you haven't seen a search engine, I thought I'd show you a made-up one. So you can ask a search engine who wrote Moby Dick, you get the right answer as quickly as electrons can fly. You can ask it, and clearly an author's name is part of what we count as metadata for a book. Look at any old library catalog card. But we can also ask it, what book has Call Me Ishmael in it? And I can even misspell Ishmael. And it will, again, immediately tell me. So content now has become metadata. That happened in the internet at mass scale. That's what we're all used to. We'd feel cheated if we couldn't find Moby Dick by some tiny string of words in it. We're really spoiled that way. But this only works because the difference between metadata and data is not as important in many realms as it was, and especially the public's perception of this, because as a member of the public, our perception of it comes from search engines, among other things. But we can also ask it something that it's not content, it's not structured metadata, it's a question like, who's that author who went up Monument Mountain in the Berkshires to have a picnic with Hawthorne? Oh, it was Melville. That's not in the books, but you can do that search. That is pretty far from being metadata, I think, but it works exactly like metadata. I can use it to recall a piece of information. Or we can ask, what the hell is my point? And the answer to that is, that everything is metadata. Everything can be metadata. That the distinction now is that metadata is what you know and data is what you're looking for. And that can be anything in many environments. The environments that have taught the public about data and metadata, especially big internet scale data. So in that regard, there's only a functional difference between data and metadata. And that's actually, it's good. The instances in which we use it, that's good. That's what we want. It also turns out that, I left the numbers in. Ignore the numbers. Darn it, I meant to take them out this morning. They mean nothing. Well, they mean something. They're like a little, this is a point I wanted to make. Okay, I'm just going to go home now. I think I got all of the pictures of our grandchildren out of the deck, but we'll see. So In fact, anticipating metadata, which is imagine if this had been an actual on a stand. Are you enjoying the rumblings of my lavalier? Is this thing on? Okay. It turns out that in many instances, certainly not all, anticipating metadata, deciding ahead of time what metadata is in any particular set, it can hide information. And if we're anticipating metadata correctly, we're hiding information that we don't want, but it does hide information. It makes it harder to find or invisible. Often that's what we want. But we've gotten used to the opposite. And we are learning, thanks to machine learning, and especially black box machine learning, that we can make tremendous gains if we destructure data and let AI restructure it. That can reveal information that we didn't know was in there. That's why we do that. And the origins of this, the near origins of it, are Fei-Fei Li at Stanford, who in 2006 thought, the current round of AI is sort of stalling a bit, and it's maybe because they're focusing on algorithms and rule-based and the rest. They're not paying any attention to data. They're treating data as if it were an afterthought, when in fact, you could just maybe gather up way more data than you think you need and let the machine figure out how to make sense of it. And so she created the ImageNet database. If this is familiar to you, I'm going really quickly. If it's all familiar to you, we'll be done with this in a moment. The ImageNet database of well-tagged, well-labeled images of objects started a competition for models, machine learning models, to see which ones did best. And then in 2012, there was a breakthrough. AlexNet not only won, but won by a significant step forward. And the weird and surprising and shocking thing was that AlexNet did not try to tell the computer how we think items can be differentiated in a large image data set. Instead, it said, okay, go ahead, computer. You figure out what are the patterns you find in these images that help you to differentiate. Just go ahead, iterate as many times as you want, and it worked. And that's, with a neural net, this is how we do things now. Again, I know enough to tell you this, but this was shocking back then. Very quickly, people saw that had evidence that this was a very good way of proceeding. So now, not that many years afterwards, 11 years afterwards, we have chatbots, AI, ChatGPT, and let the record note that the first reference to a chatbot came at 10 minutes and 37 seconds. We have chatbots that absolutely blow our minds. I'm using blowing our minds as a technical term. I mean, it's what happens for all of us when we try these things out and our heads get blown back, pretty literally. I mean, how did it do that? How did it know? And we can't figure it out, and in many cases, in most cases, neither can the people who created these. So why? Well, because humans are terrible at scale. I mean, that's the true answer, I think, and it's an important answer. It's not the only answer. Why? So I'm going to ask again, why do they blow our minds? Second answer is also, I think, true, because that's exactly what they were designed to do. Right? Let's build something that will just blow people's minds with how conversational and human-like it sounds, and it also knows more than anybody that you've ever talked to on the planet. So they did that. The third reason is the more, not serious. I think the other two are actually quite serious. But they work by finding patterns in word usage, as you know, and the data set is larger than the internet. ChatGPT-4 won't tell us what its sources were. For ChatGPT-3, it was the internet and Wikipedia, and weirdly, any link in Reddit that had more than 3 upvotes. That sounds a little risky to me, but that's what they did, and some set of books. Unbelievably large corpus that they're working with, data set. And so they find patterns in word usage. Okay, good. I mean, that's roughly how it works, right? But we can then ask, Why are those patterns there? Why does our word usage have patterns? Because that's at the basis of this whole thing. And it's for what I think is a pretty straightforward reason. This, by the way, most of these illustrations are from one of the AI generators. This was DALL-E's idea of, give me an image of love in a digital art style. Okay, so the reason there are patterns there is that we write about things that matter to us. Writing is an effort. We write about things that matter to us for any of the gazillion reasons why things matter to us. And then, because we're writing, if it's going to be in this corpus that's being trained on, we've shared it. One way or another, we put it out for some other people to see. That's why there are patterns in the language set that it's being trained on. These chatbots are being trained on. It's because humans write things that matter to them, and they matter to them, and we share them because we care about them. So at the bottom of all the tech is this raw fact that humans do things that matter to them, or to us, I'll count myself, and because we care about things in the first place. So underneath all of the data, in the chat stuff, but also I would say all of the data that we gather, is this two human layers, which are very closely associated. That we are creatures that care about things, and our cares clump together socially into shared objects of interest and concern, things that matter to us. So this is one of the things that I think data reveals to us. It's not a great startling revelation, but it is one that is often forgotten, that we are fundamentally creatures who are not mechanical, but who are characterized by the fact that things matter to us. Nothing matters to AI. If you ask me, and you didn't, I would say it never will for reasons we won't talk about. But to be human is to be affected by things, to care about things. However, all caring is a type of bias. It doesn't mean it's bad bias or prejudicial bias. What I mean by that is a bias is something that you believe in quite firmly. It shapes your views, but you don't have good reasons for believing in it. And so some of the biases are obviously, usually when we use the term, especially with regard to AI, we're thinking about terribly prejudicial biases that AI is prey to because AI's original sin is bias. It's reflecting the bias in data, unless great care is taken all along the way. Well, AI shows us how pervasive bias is, both in the outcry about the many, many instances in which AI models have been shown to be perniciously biased in ways that we need to be angry about and to do everything we can, technically and in any other way, in order to try to eradicate that bias from AI. But biases, by their nature, are hidden from us. We don't know we're biased. Biases are underneath. They're shaping what we see, and the bias itself is usually not apparent to us. AI shows us that that is the case, that bias is hidden from us. Again, none of these are going to be great revelations. They're all things that we know, but they're not things that are usually at top of mind. So AI shows us how pervasive it is, and that, in fact, every bias hides itself. By its nature, it hides itself. And so we are always living in a world that is hidden from us, our own world that is hidden from us. So biases also play a very positive role because they, for example, the things that we value and that we value deeply, and we value so deeply that if we run into somebody who doesn't value them, we say, well, I can't even talk to you. Are you crazy? There's something absolutely wrong with you. You don't see why it's wrong to, and then put in whatever, or you don't care about whatever. Those biases are positive, but they're also hidden from us. These are biases that, in a philosophical term, situate us. So we are who we are because of where we were born, when we were born, our history, our culture, our language, our family, our religion, our community, our experiences. Those are the things that make us what we are. If we didn't have any of those, if we were born in a capsule floating out in space, and we'd be a different sort of human, biologically human, but not recognizable otherwise. We are situated creatures. And we can't get past our situations to some abstract place where we're free of all of what made us who we are. The way in which AI inevitably encodes bias reminds us of this. And when we are reminded how biased AI can be in pernicious ways, we can also be reminded that, yeah, but it's also biased in the same ways that we are, in ways that are not negative and harmful. So we often hear the phrase, we don't know how it works, and sort of in a panicked voice about machine learning, especially stuff that's inexplicable. And understandably, because there's lots of dangers to AI that when we don't know how it works, particularly in some situations. I'm going to venture that it matters more for using AI to sentence prisoners or to do bail setting than it is to use inexplicable AI to predict the weather. So it varies by case. But there's a great deal of understandable and deserving anxiety about the fact that these are black boxes. But there's another part of this phrase, we don't know how it works, said in some real deep anxiety, which is 6, apparently. It works. Sorry, I should have gone back. I'm not going to. The stuff works. Every time we or someone says, we don't know how it works, we are acknowledging it works. And the fact that it works tells us something really important about how the world works. The fact that these things work, but we can't understand it, probably tells us, I think correctly, but you may disagree, that the world is in fact the black box. The world, it only works because the complexity and chaos that makes these things inexplicable to us is in the world. And these machines are capturing more of it than we can without these machines. That, I think, is a really important way in light that AI is shining on the world. Not that we don't know how it works, that's important too, but that it works. This black box of complexity and chaos works. It tells us something that's really important for us to hear, which is the world is beyond our knowledge. And believe it or not, in the West, we have not always thought that. We thought that the world was run by a handful of relatively simple rules and laws and that we could understand it. AI is saying, well, no, we'll do better. We'll know more about the world, make better predictions if we don't have those. We don't start from those big laws. Let's start from the chaos. So the world is beyond our knowledge, and yet with AI, it's determined enough for us to get useful outputs. We don't know how it works also reminds us that we just don't do scale very well. And I think that AI shows us how we compensate. That's always been the case, of course. AI, I think, is showing us some of the ways that we compensate for that weakness in human brain and human thought. We just, we can't do scale. So what do we do about that? Well, generally what we do, in the West, has been to focus on universals and generalities and laws and principles of all different sorts in lots of different realms, whether it's physics or it's moral thinking. We believe the highest truth is in the most abstract and general ideas. And then we use those generalizations, we apply them to instances. That works. We've made a lot of progress that way. Those generalizations frequently are quite true. I'm not going to argue with Newton or Einstein. But we also pay a price for it. So because generalizations tend to reduce things to commonalities. So let's say you're going to do something simple and you're going to separate images of dogs and cats. And you can do it by hand, you can use a machine to do it. In doing this, you are ignoring all the differences among these adorable animals, right? You're saying, okay, good to do, for whatever purposes, we have some reason to do this. We're going to treat the ones on the right as dogs, even though some are big, some are small, some are cute, some are not so cute, et cetera, and the ones on the left are cats. Generalizations, these sort of laws and principles, simplify. They simplify them enough for our brains to process them, which is why we in the West have preferred generalizations to particulars. It's also the case that these sorts of generalizations give us power. And the power we use well, power that we use terribly. But unlike machine learning gives us generalizations, of course. If a model can't generalize, then it has failed. So we want something that we can feed in any image, and it's going to give us back the right, in this simple example, the right object that's in it. But machine learning generalizations don't do what we've wanted traditional generalizations to do. For one thing, they are really complex because they are based upon lots and lots of patterns, some of which may be too complex for us to understand, and how they go together may also be too complex for us to understand. They don't reduce, at least not nearly as much as traditional generalizations do. And as a result, we may not understand them. Why did ChatGPT say this? We're not going to know. Why did it, et cetera. You know the problems with uninterpretable AI. So they don't let us understand things. We can't apply them. So we have to use the model, right? We have to run the thing through the model. We can't sit down with a whiteboard and apply them. And this may seem like just a technical nit, but it's not, because part of being able to apply them is the power issue. We have control. We can apply the generalizations when we want to. Now we are, for this sort of stuff, we are increasingly dependent on machines in a way that we have not, because we can't understand. We are ceding power to them for our benefit, but nevertheless, it's a transfer of knowledge, of power, and it's based on the power relations inherent in Western knowledge. And finally, machine learning generalizations are different in that the particulars maintain their voice. They don't get absorbed by the generalization about gravitational attraction or force, mass, and acceleration or whatever. These generalizations, machine learning generalizations, embrace the particulars that enable it to distinguish all those dog and cat pictures without reducing them as far as old-style generalizations would have. So they're not doing, yeah, they generalize, but not in the way that we have wanted them to do in terms of how we view ourselves in our world. So this is a slight digression. It's not a digression. It's just going to sound like one. This, I think, this change in this new valuing of particulars as at least equal in importance to generalizations, I think is revolutionary. I think it's a deep, deep change in Western culture. Because one of the characteristics of Western culture has been that we have looked for frameworks, general frameworks, whether it's theories in physics or, in this case, it's moral theories. And in the West, we have a number of well-known frameworks. These are just 3. Usually there's 4 or 5 up here, but I don't care about them. They're just examples. So, for example, religious ethics. I'm boiling this down way too far, but I'm okay with it. Why is lying right or wrong? Well, it's what God says. Under principled or deontological, you ask, why is it wrong to lie? Well, because there are logical reasons. If you're going to be reasonable, there are reasons bound. An examination of reason will show you that it's unreasonable and illogical to lie. And utilitarian or consequentialist, which I'm sure everybody's familiar with, says, well, okay, here's our framework. Do what results in the most happiness for the most people. Those are frameworks, right? They should apply to everything. And if you come up with an example where principled gives you the wrong answer, that's an argument against the principled approach. The typical example in the principled, the usual example in the realm of the principled is that, well, if you're not supposed to lie, suppose the Nazi, sorry, there's 2 Nazi mentions in this talk, I'm really sorry. But the typical example is you're harboring Anne Frank during World War II, and a Nazi soldier comes to your door and asks, is Anne Frank there? And you're not supposed to lie, so you say, yeah, she's upstairs. Most people would say, no, that's the wrong answer. Your principles of philosophy steers us entirely wrong. That would be an argument against it. If you came up with situations in which the framework fails, and you can come up with those for all of these, in fact, all of the frameworks that we know. So I'm going to give you the world's simplest moral problem, okay, on purpose. I know this is not of any tremendous consequence. But let's say you have a friend. You're the smiley person. You have a friend A. And A is arguing with C, who's also your friend, C is friends with B, who is also, this is a little group, you all know each other, you're all friends. And A says to you, oh, I just told you how angry I am at C. Please don't tell B about that. I don't want it to get out. And you say, yeah, okay, I won't mention it at all. But then B, almost done, B tells you, oh, want to see the seating plan for my wedding? And you say, sure, and you notice that B has seated A and C next to each other. What do you do? It's not a thing of great import, but how you decide it is not through frameworks. You have to examine all of the particulars of the case. It depends upon how angry would B? How do you feel about breaking a promise? What will that do to your relationship with A? How bad would the clash between A and C be at the wedding? Would it really disrupt things, or would B not even notice? How upset would C be? Et cetera, et cetera. You would consider all these things, you'll make a decision. I don't know what's right or wrong, but I know that there's no framework that will solve this for you because it's all particulars. And what's worse, or better maybe, is that next week you have roughly the same issue, except it's different people. Now C is angry at B, and et cetera. It doesn't matter, but the point is the same structure. You cannot apply what you figured out for the first instance a week ago and just say, okay, I'm going to reapply that to this. I solved that problem. This is the same problem, same solution. No, you're going to have to sit down and think again about everything. It's not a wedding. It's a barbecue. Does that matter? And B is more forgiving than A is. The point is that morality is based on particulars. No two situations are commensurable. They're not the same. You can't reapply and just say, okay, you have to examine the particulars. And I chose a stupid little example on purpose because our lives are filled with this. This is actually more dramatic than most of the moral decisions you're going to make here today, probably, I hope. There is a philosophy that says morality is about particulars. It's among other things, but that's important in this philosophy. It's called the ethics of care. It's about 30 years old. It is a deeply feminist philosophy, and it's having a remarkable amount of influence for lots of reasons, including that they're right. And I think they're certainly right about this. The focus on moral decisions as being always within the framework of particulars and people and things that you care about, that matter to you. Bad. Okay, almost done. So, machine learning is a lot like that in its own way, because you feed in some distinct piece of data, an input, and it's going to use a set of very particular tests. And it's hard to know what's going to happen the next time you feed one in, even if there's a small difference, because a small difference can result in a different outcome. So you're generally not getting generalizations out of a machine learning system. It has access to a finer level of detail than old-style computing, if you will, had, and that we have thought was necessary, because our culture in the West is focused on universal frameworks, on generalizations. So I think that we're seeing a humanizing of data. And let me tell you, what I mean. That would be good. So data, I think we'll agree in this room that data is not a property of the world. It's not a property of the universe. It's a property of that develops depending on our desire and ability to measure it and how we measure it. It depends. It generates in a material world. It depends on where we put it and why we put it and how good we want to make the machinery. Data is essentially, in this regard, the numbers that are read off of a gauge, and we get to decide what gauges we need. And we do. We generally make good choices about what to measure because we have something in mind that we're trying to do. We decide how we're going to measure. We decide what the units of measurement should be. And what degree of accuracy is acceptable. And a whole large, you know the rest of it way better than I do, issues about who gets to see it and what its lifetime is, et cetera, et cetera. This is something that we craft. We don't make the numbers up on the dial, we read them, but they are there because we made those decisions. Which means, in an odd way, that data is situated just the way that we are. We are situated by our culture, language, family, et cetera, et cetera. Data is situated by what we as situated people want, what matters to us. That's how we decide. We decide how much to invest in which parts of the world, what level of data, how intrusive it can be, how private we have to keep it. All of that is situated. It's not, no abstract answers here. And there's no data unless we go through the process based upon our assumptions, biases, and intentions, all of which arise from our situation. Which is to say that data serves and expresses what matters to us. So here's where we started. Won't go through it again. Here's what I think is changing. We're seeing data, I think, expressing more explicitly expressing what matters to us. In arguments or discussions around the politics and ethics of AI, this is explicit. All right? Why are we doing this? Why are we going to all the trouble and expense of creating a machine learning system? What are we trying to accomplish? Which means, in this sense, that caring, something that we care about, is the new oil. Maybe it's the new solar panel. Make me happier. We are data at such scale that we now are getting use out of, initially on the internet, and then the blown out scale in machine learning. It depends upon the world's complexity and its chaotic nature. We are thriving not by imposing the tightest order possible on data in order to ensure results with some integrity, but in some instances in the world of AI and on the internet and other places, by removing the order, letting the order emerge, not imposing it. It is exposing to us, by its success and by the fact that we can't understand that success, how it works, it is leading us to think, I think, that there has been a price that we've paid for sticking with generalizations. At the same time, and for the same reasons, it's simultaneously convincing us by showing us the value of particulars. Also, very importantly, body level 3. That's, by the way, my body is body level 3. Trying to get it up to a 4, but probably not going to happen. And finally, that data, which we had thought of as mechanical and alien and anti-human, is becoming a carrier of meaning, not mere numbers and bits. A carrier of meaning, and meaning is always situated, which makes it far, far more human. So in all those ways and in others, I think data is in the next 5 years, 10 years, we will look back at how we have been thinking about data and how we think about it now. And we may say, it's a fundamentally different idea of what data is. Thank you very much.